Welcome back, Math 30-2. Today we are going to look at polynomial functions of degree 0, 1, and 2. Most of this is going to be a review of years of grade 9, 10, and 11. Degree 2 we focused a lot on last year when we did parabolas and quadratic functions. Degree 1 and 0 we've been doing for a while, grades 9 and 10. So here we go. We're going to first look over here at these polynomials. So a polynomial is something with one or more terms. And this polynomial here has 3 terms. Now the degree is looking at the largest term. So the term with the variable with the largest exponent. In this case, the degree is 2. The constant term is the one without a degree, or without, a variable in it. So in this case, it is -5. Take a look at our next one, and it says the degree of fx 2x minus 4. Well, there's an imaginary 1 here because it's x to the power of 1. So it's a degree of 1. The constant term for this one is -4. Okay? Now, let's take a look at this one. If I said y is equal to 3, or fx is equal to 3, it's really like saying x to the degree of 0. So in this case, the degree is 0. Because what is x to the power of 0? Anything to the power of 0 is 1. So that's all it is. Now here we're going to look at the next definition that you need to know is leading coefficient. Very important term. So the leading coefficient is the number in front, or the coefficient in front of our biggest degree, our variable with the biggest degree. So in this term right here, it is 1. Because there's an imaginary 1 in front of the x. In this term here, 2x is our leading term, so our biggest degree is 1. Our leading coefficient is 2. Okay? So the next part here wants you to make up equations to satisfy that, and I'll let you guys do that on your own. Okay. So now we're going to investigate equations with a degree of 0. And what does that look like? So here's our first graph. It says fx is equal to 3. Well, isn't this kind of the same as f of x is equal to 3x to the power of 0, since x to the power of 0 is 1, 3 times 1. So no matter what x is, if x is a billion to the power of 0 is 1. -1 million to the power of 0 is 1. 0.0005 to the power of 0 is 1. So then it's always 1 multiplied by this number, 3. So no matter what the value of x is, my y value is always going to be 3. So y is always equal to 3. So what is the domain of this function? Well, my domain is all possible x values. So my domain is x such that x is an element of all real numbers. Okay? So what are 2 others that can be graphed to 0? Well, what about this? F of x is equal to 2. Well, that's going to be just a line going straight across like that. Another one would be maybe 1/2 or 3. I just did one more. You could do others. Okay? Now, what else do we notice about these lines is every time we have a degree of 0, it's just going to be a perfect horizontal line going straight across. Because it doesn't matter what x is, my y value is always going to be the same. And if I look at this, what is my range of this one? Well, y is equal to 3. This one here, y is equal to 2. It's the only thing y could equal to. Describe the shape of the graph, it's always horizontal. The number of y-intercepts, well, there's only one y-intercept because y can only equal one thing. And then if I said, what are the x-intercepts? Well, there's none unless I said f of x is equal to 0. Then there is unlimited x-intercepts. Otherwise, there are no x-intercepts. Okay? So here, they're just generalizing it. It says, generalize the above work. So the graph is a straight line. Straight, or horizontal, I should say. Horizontal line with a slope of, well, there is no slope, 0. The domain is, x is an element of all real numbers. My range is my constant. Whatever the value is. Okay, there are no x-intercepts. There are no x-intercepts for the function. There are no for the function. Okay, well, there are no x-intercepts except for the function where f of x is equal to 0. There is only one y-intercept, okay? Now it says, does the value of a polynomial function of degree 0 depend on the value of x? Well, no, we just went over that earlier. It doesn't. Okay, so next one is degree of 1. Now we've done this in grade 10 and a little bit in grade 9. We have some key terms here to look at. First, I'm going to look at this part here. Now in this graph, what do you think this 2 represents? Look at where it crosses. It crosses right here at 2, where it crosses the y-axis. The y-intercept is 2. Here, this negative 4, y-intercept is negative 4. Look at this one, y-intercept negative 4. This one here, the y-intercept is 0. So what do you think this last term means? Right here, we call it b. That's interesting. The next one we're going to look at is, what do you think this 3 means in front? Well, I look at this, and every time I go over 1, I go up 3. If it's 2, every time I go over 1, I go up 2. Look at this, negative 1/2. Every time I go over 1, I go down 1/2. Every time I go over 2, I go down 1. So every time, because it goes down 1/2. Every time I go over 1, I go down 1/2. So if I go over 2, I go down 1, because that's 2 halves, right? And the last one, same idea. Interesting. So, the shape of the graph is always a straight line. Is always a line. This is a straight line with a slope of m. Whatever this value here, that's always my slope. The domain is, well, look, each one of these graphs go forever left, and they go forever right. So the domain is x is an element of all real numbers. This is if we have a degree of 1. Because look at all these, the degree is 1, 1. It's just x. X is degree of 1. Okay? The range is, well, y is an element of all real numbers. There is how many x-intercepts and y-intercepts? Well, if these are straight lines, there can only be one x-intercept and one y-intercept. It's a straight line. And the y-intercept is always b, this constant here, the constant we are adding. Okay? So if the leading coefficient is then the slopes from quadrant 3 to quadrant 1. So if we go over this here, this is quadrant 1, 2, 3, 4. So from quadrant 3 to quadrant 1, that's going from left to right. If we're going that way, we are increasing. So that means the slope must be positive. Now from quadrant 2, if it's going from quadrant 2 to quadrant 4, there's 2, there's 4, I must be going down. Because we go from left to right always. I'm going down. Think of going down. So you're skiing down, so it must be negative. We're declining. So this one here is negative. Since the graph of the polynomial of the degree 1 is a straight line, this type is also called a linear function. All right? So now here's our last one. This is of degree 2. So we're looking at polynomials of degree 2 here. So for each of these, notice degree 2, powers are 2. These are also called, if you remember from grade 11, a parabola. All right? Now there's some interesting characteristics. This coefficient is important. There's a 1. If our leading coefficient is positive, we are happy. We are positive people. We are happy. That means we make a happy face. My graph looks like a happy face. Okay? The bigger the coefficient, the bigger the positive number, the happier we are. Okay? So this would be like a 10 leading coefficient, like 10x squared. Now I'm going down, that's like 6x squared. Go down more and more and more. Oh, that's like x squared. Oh, then all of a sudden, I am going down. Now I'm sad. That's going to be like negative, negative, and it keeps on going down. So you're negative, you're getting sad. Now, also, if it's positive, that means you're happy. You only have a minimum. You can only be so low. If it's negative, you're negative. You're down in the gutters. You're sad. There's only a maximum of how good you can feel that day. But you could go down. Or like you just feel like you could go down forever. So for all of these, the domain is what? Look at these graphs. They always go as far over this way and as far over that way. So my domain is always x is an element of all real numbers. My range. Now my range matters. Okay? My number of x-intercepts, there's either 1, 2, or none. The maximum we can have is 2. Y-intercepts, there's only one y-intercept. Okay? Now, how does the y-intercept relate? Well, it's just like all the others. Whenever we see a constant, what is the y-intercept? It's the constant term. Hey, look at these. These here are negative. This is going down. Negative. Y-intercept is 10. It's constant. 10. Constant. There we go. That's pretty much it. My range is either greater than or less than the max, or my range is greater than the min, or equal to. So those are my two ranges. Okay, it could be either less than or equal to the max, like this one. It's negative, negative coefficient, so it's down in the dumps. It's negative, it's going down, and there's only a max of how high you can get because it's negative. So it has to be less than or equal to the max. But when it's positive coefficient, leading coefficient, then what happened? You're up there. Yes, you feel up. You can only go down so much because you just feel ready to go. So it's going to be unlimited maximum. So it must always be greater than your minimum because you have a minimum. You have a minimum. Okay? And the y-intercept is always your coefficient. Not coefficient, sorry. It's always your constant. Both C words. Okay. So the graphs have parabolas opening up or down. Turning point, they all have one turning point, which is either the maximum or the minimum. So the turning point. So the whole idea of that is if we follow this, this is turning there, it's bending this way, then all of a sudden it's bending the other way. So your max minimum, known as the vertex, is your turning point. It's bending this way, then all of a sudden it starts bending that way. Okay? So how can you tell the equation of polynomial whether the parabola opens up or down? Well, if a, or the leading coefficient is greater than 0, or sorry, it's greater than or equal to 0, then it's up. If a is less than or equal to 0, then it is down. Okay? Because if it's positive, we're up. We're positive people. We're up. Sky's the limit. It's negative, we're down. Okay? So, how can you tell the equation of polynomial whether the turning point is a maximum or minimum? Well, if you're positive, you have a minimum. So if a is greater than or equal than 0, we have a min. If a is less than or equal to 0, then we have a max. Because you only have a maximum how good you can feel. There's only so much that can push you. Whereas, okay, same idea. There's a min, smiley face. There's a minimum of how much is going to get you down today. Otherwise, you're just going up. And the max is, well, everything is down. Just feel like down. You just can't get up. Okay? So it can be written in form y equals, so the range can be written in the form of y must be greater than or equal to a, so a number, the number, so to our min. So this way, it must be greater than or equal to our min, or y is less than or equal to our max. This is kind of just a repetition. So here's an example. We're looking at this equation here. Okay? Now, what are the x-intercepts? Well, the x-intercepts are, if we factor this, we put each of these equal to 0. So this here, we make it equal to 0, because my x-intercepts means my x value, or my y value is 0. So I have 0 is equal to this multiplied by this. Well, if this is 0, then it doesn't matter what this is, because that's 0. So I'm going to get, I solve for x here, x plus 1 is equal to 0. So x is negative 1. And 5. So we have two x-intercepts at negative 1 and positive 5. Okay? Take a look at this one here. It's factored completely. What are my x-intercepts? Well, I'm going to have we have two x-intercepts again at negative 1 and positive 5. And the last one here. Look at this. It is right there. How many x-intercepts do we have? We only have one, and it is at 2. Because it's squared. It's the same x-intercept for both, so it's squared. So there's only one of them. All right? Now, state the zeros for each function. So, for these here, what are my zeros? My zeros that's the same thing as when we graph. If I was to graph this, I have an equation here from before. So, type this properly. And here's an equation. I want to calculate the zeros. That's the same thing as, so I calculate, I go left bound, use the calculator, I put enter, enter, enter. So there's 0, 1.5 and 0. So the zeros is the same as my x-intercepts. So in this case, it says state the zeros of this function. That is my x-intercepts. So that in this case, it's going to be, if I was to graph this, I would find out my x-intercepts are 1 and -6. Okay, for p. Now for qx, for the function of q of x, my x-intercepts are going to be just -3. That's it. Okay? Now for px, the direction of the opening. Well, px, we have 7 in front. If I was to multiply that out, I just expand this out here. I'm going to end up getting 7x squared, and then I'm going to get plus 6x, and I get -6, or plus 5x minus 6. And I multiply, I'm going to 7x squared plus 35x minus 42. I look at this, I know right away it is positive, it is opening up. Okay? The number of x-intercepts, well, looking at this, there are 2. The value of the x-intercepts are 1 and -6. Okay? And then the value of the y-intercept, well, I had to multiply it out into this form. It's going to be -42. We need this form to find our y-intercepts. We need this form to find our x-intercepts. Let's take a look at qx. All right. We want this one here. Well, it's negative. So no matter what, when I square this, I'm going to end up getting x squared plus 6x and then plus 9. If I square that, and then we have to multiply that all by negative. So we're going to -x squared minus 6x minus 9. Well, take a look at that. What is this opening? This is opening down. My number of x-intercepts, there's only 1 because of that form. There's 1. What's it at? It's at -3. What's my y-intercept? -9. Okay? That's how that one works. All right. So we are almost done here for this first part. We're just going to look at this and say, degree of 0 is always a straight line. All right? Next one is degree of 1. Well, if it goes from, okay, figure B, the leading coefficient of the graph is positive. Figure B of the tail goes from quadrant 1 to quadrant 2. It increases. It goes from, quadrant, if we go like this, 1, 2, 3, and 4. It goes from quadrant 3 to quadrant 1. Okay? It goes from left to right. Okay? And this means it's a negative as it decreases. Okay? Now let's take a look at this. If the leading coefficient of D tail, the graph goes, okay, leading coefficient is positive in figure D, the right tail of the graph goes forever right, and this one goes forever left. Okay? They still go, so pretty much it always goes in the same direction. This part here is just minor things. It's just the end behavior. They go forever up, or goes forever up, and this one's forever up. This one here goes down and down. Okay? This one here, it goes the left tail. So the right tail, this is this tail, it goes up. Left tail is down. Here, the right tail goes up, or then the right tail of the graph, the right tail goes down, and the left tail goes up. So in that case. So here we go. Complete the graph. Left tail, right tail for this one. So I am negative, negative 2. So my left tail. So if I'm negative 2, my graph looks like this, right? Oh, sorry. Negative 2. My graph is going to look like this. So my left tail is going up. My right tail is going down. And my natural turning point, there is none. Okay? We're looking at 2x squared minus 7. Oh, 2x squared minus 7. So it looks like that. Okay? So we have to look at this. 2x squared minus 7. Well, first of all, it's positive, so it's going up. So we're both of these are up and up. What is my nature of the turning point? It is my, what is this value called? In this case, it's my minimum. Okay? Now we're looking at negative 5 plus 3x. Ah, my leading coefficient's positive. So this one's looking like that. So my left tail is down here. It is down. My right tail is up. There is no turning point because it's a straight line. My last one here, we have a negative x squared. Leading coefficients there, it's negative, so this is going to be down. So they're both going down. Left and right are both down, down. And if I look at this also, where is my turning point? It's the vertex, and that is a maximum because I have a maximum there. And that's everything. So good luck. Hopefully you understood this, and I'll see you tomorrow as we work on the assignment.